Hi, and welcome to section 4 of scikit-learn recipes. In this section, we are going to explore support vector machine in scikit-learn. In the first video, we are going to build a linear SVM model. In the second video, we will be optimizing this linear SVM model. In the third video, we will be building a multi-class classification SVM model using consumer complaints data. In the first video, we are going to look at building a linear support vector machine model. So we are going to build this model using a breast cancer data set. You can download the data from here. So here is a little information about the data set. These are the variables. Click on this over here to download the CSV file of the data. You can also find this data set on UCI's machine learning repository. Once you've downloaded the data, you can load it right here. Now, our data frame has this ID column and unnamed 32 column, both of which we need to drop. Now that we've dropped this, let's look at our data set. So this column over here is the diagnosis, whether the cancer was malignant or benign. So if it's malignant, we are going to give it the number 1, and if it was benign, we are going to give it the number 0. And let's create a new column called diagnosis that will map this right here, this binary classification, onto the diagnosis column that exists right now. So before we move forward, let's look at what a support vector machine is. It is a binary linear classification whose decision boundary is explicitly constructed to minimize generalization error. It is a very powerful and versatile ML model. It is capable of performing linear or nonlinear classification, regression, and even outlier detection. It is well suited for the classification of complex but small or medium data sets. Not really great for very large data sets. And if the observations are linearly separable, SVM fits decision boundary that is defined by the largest margin between the closest points for each class. This is commonly called the maximum margin hyperplane. So let's run a really quick support vector classification, a linear SVC on this data. We have to split our data into training and test set, and let's create SVC model object right here. And we are going to now predict the accuracy, which is 91.23%. Now, as you can see, our number of observations is very low, but what this has done very well is that it has predicted that 0 observations to have malignant cells when they actually do not, which is really good, which means that it has not flagged existing malignant cell as non-malignant one and saved these lives. What this means over here is predicted to be malignant, but is not malignant, which is 0. So it has not incorrectly predicted a malignant cell over here, which means that it didn't make anyone super nervous. But this is the worrying part where it has predicted something as benign and it has actually been malignant. And in this case, 10 people actually are at risk, but were predicted to be not at risk, which is worrying. And this model needs to definitely improve because we are very okay with predicting someone having cancer, but then them actually not having cancer versus predicting them as not having cancer and they turn out to have cancer.